Hello guys, welcome back to Math Zone African Motives. Still working on mathematics and working on our trigonometry. We had the introduction in the first part. Now we are going to have the simplification and proving part of identities. So sometimes you are given the simplification part. So I'm just gonna recall a little bit from our previous class. Remember, I referred in our previous class the use of quadrants, if you still remember this part where we talked about the first quadrant, all identities or all the trigonometrics that you are going to have, ratios are going to be positive. In the second quadrant, it's only sine which is positive, and the angle there is 180 minus x. In the third quadrant, the angle is 180 plus x, and in the third quadrant, it's only tan which is positive. In the fourth quadrant, the angle is 360 minus x, and it's only cos, which is a positive there. All right, so let us see how we are going to refer to this information with these questions. So the first part we are given here was use basic trigonometric identities to simplify the following. All right, so let us see how it is going to reduce. We are given sine 180 plus x. So if you are to take note, 180 plus x, this one lies in the third quadrant, all right, from our trigonometric part that we had. 180 plus x is in the third quadrant, and in the third quadrant, the only tan is positive, meaning to say sine is going to carry a negative. Sine 180 plus x is going to be given as minus sine x. So this is what you simply need. You have reduced this to minus sine x. So this is going to be reduced to minus sine x. All right. Then we are going to have the square root of cosec squared 360 degrees minus x. So remember that cosec, what we need is that what is affecting cosec, because here there is 360 degrees minus x. So the part that has got cosec has to be affected with the equivalent of that cosec that we are given in this case. All right, but 360 minus x, remember, okay, let us get first the cosec of x is equivalent to 1 over the sine of x. So meaning to say, if we are given cosec 360, is going to affect the same thing, is going to be 1 over the sine of this. But as we want to concentrate to say it carries the sine, it carries sine x. So meaning to say, if it carries sine x, what is going to happen with 360 minus x where there is sine in 360 minus x? All right, so let us get to our quadrants. 360 minus x, we are going to see that in 360 minus x in the fourth quadrant, sine there, it's a negative. So like I was saying before, that everything that is affected to sine x is also affected in terms of the sine. Sine is affected to cosec. So meaning to say, even if we are given the cosec here, the cosec of 360 degrees minus x, we are going to have our answer as a negative in this case. All right, so because sine there, it's a negative. The sign that you're obtaining, it's a negative. So meaning to say, this is going to give us negative cosec. So we are going to obtain negative cosec x in this case, because sine is a negative. So cosec also is going to carry a negative, because cosec carries sine in its simplification. So meaning to say, we are going to have a negative where there is cosec 360 minus x. All right, so let us get here. There is cosec 360 minus x, but take note, this one it's being squared. So it is going to be minus cosec of x like this, because we said it's going to carry a negative, but being squared. So the moment we square this, it becomes a positive. So we are going to have the square root of minus squared, which is going to be positive, cosec squared. So we are going to remain with cosec squared x minus 1 like this. The minus 1, let us just leave it like that. All right, so this is how we can reduce this identity. I mean, the ratios that we are given. Everything now is divided to the square root of, we are back again. So we are going to apply this one, 1 plus, this one is direct tan 360 minus x. So we need tan 360 minus x, which is in the fourth quadrant. Remember, 360 minus x in the fourth, and tan 360 minus x is equal to minus tan x. So meaning to say, here there's a squared, so it is going to be minus tan x like this squared, which is going to be a positive. All right, so you're going to have positive tan squared x. All right, multiplied to, so the answer here is going to be multiplied to cos 180 minus x. 180 minus x, which quadrant are we talking about? This is the second quadrant, and we said in the second quadrant it's only sign. In the second quadrant it's only sign which is positive, so meaning to say 180 minus x there, cos 180 minus x is equal to minus cos x. So this is going to give us minus cos x in this case. So this is how you play around with these values or with these ratios. So we've got minus cos x there, multiplied to cot 180 degrees plus x. So what we want there is the cot it's from tan. So tan 180 plus x, meaning to say, want to check what happens with tan. If tan is a positive, also cot is going to be a positive, but this is 180 plus x, which is the third quadrant. And I said in the third quadrant, tan, in the third quadrant, all right, here we are going to have our tan being a positive in the third quadrant. So meaning to say cot is also positive because it's from tan. Remember, cot 1 over tan of x gives us cot x. So if tan is positive, cot is also positive. That is the idea there. So meaning to say this cot is going to be a positive. So we are going to have cot of x. So we are going to have cot x being positive. All right. So this is how we have managed to reduce the first part to this. All right, so let us now play around this and see what you're going to have at the end. Cos x squared minus 1. Remember, from our identities also, let me show you from your formula sheet. There's another part that you are given. Some of these ones you are given from your formula sheet, all right, but I explained from the first class. If you check here, we are given some of these identities, that is from our Pythagorean identities, from sine squared 1 plus times this part. So there you have to play around these identities to make what you want the subject from there. So these are the ones that I'm going to work with from this simplification. But as here we are referring to the cos x squared minus x. So meaning to say we have to play around with where there is cos x squared. And where there is cos x squared, we are told that 1 plus cot squared x is equal to cos x squared x. So what made us to have cos x squared minus 1? We simply transferred this to the right-hand side. So meaning to say we are going to remain with cot squared x equal to cosec squared x minus 1. So where there is cosec squared x, it is equal to cot squared x. So that means here we are going to have minus sine of x times the square root of cot squared x in this case. All right, everything over 1 plus tan squared. Remember from our identities, 1 plus tan squared is directly equal to sec squared. 1 plus tan squared is equal to sec squared from those identities that you are given. So this whole part can be reduced or can be given as a sec squared. So we are going to have the square root there of sec squared x. All right, multiplied to, so this part we've got minus cos x. Let us just remain it as it is. All right, or we can just remove this negative here. Okay, no problem, we shall remove it later on, times cot x. Remember, cot, I explained in our previous, in the introduction part, that cot is equal to cos x over the sine of x. Also, let us check if we are given this part, because some of these ones you are given, like I said, some of this part you are given. Let us check what we are given. This is the only part that you're given. So as you can see, that part, yes, we have got it here. Tan and cot, we are also given this part. This is another part that you are given. So some of these ones can be an advantage where you are given the answers, where you are given the equivalent. You just have to play around with these ones. All right, so this one we are given is an advantage. So this is going to be cos x over sine x. All right, so let us have the cosine of x over the sine of x in this case. All right, so here the square root is just affecting from here. Let me just put the square root so that we don't confuse here with there's a square root here. All right, so if we are to check, we can simplify the square roots because there's a squared. Remember, the square root of x squared is x. So meaning to say here, if there's a squared, you're going to remain with cot x, but we can also cancel the minus here and the minus at once, so that this is going to give us the sine of x multiplied to the square root of cot x, which is going, of cot squared x, which is going to give us cot x. But we know that cot x is equal to sine cos x over sine x. So meaning to say here we are going to have cos x over sine x from what? From cot x. It was going to give us cot x, but let us just simplify at once, guys. We might have a lot of stages. All right, then here we've got the square root of sec squared, which is going to give us sec x. But remember, sec x is equal to 1 over cos x. So at once we are going to have 1 over the cosine of x times, here there's cos x. Remember, negative cancelled. So we are going to have the cos of x multiplied to, here there's cos x over sine x. We've got cos x over the sine of x here. All right, so once you're at this stage, you can reduce whatever that you see. This one as it is the same as this one, so this can actually cancel at once. All right, here we've got cos x and cos x cancelling, meaning to say we are going to remain with sine x on top only. So we are going to remain with the sine of x over 1 in this case, of which sine x over 1 is equivalent to the sine of x. All right, so that is how you play around the quadrants, reducing of angles. You need to know the application of the quadrants, like I said in the previous class, that you are supposed to memorize and check your quadrants very, very much, and also to use the basic information that you'll be given from your formula sheet. Let us check the other part of the question. In this case, same approach, but now we are asked to use the basic trigonometric identities to prove this part that we are given here. Now it's a proof, meaning to say they could just have asked this question on this part alone. Simplify. They will ask you to simplify this using the basic trig identities. After simplifying, you're going to see that your answer is going to be equal to cot x. Now they want you to prove, which is simply a play around type of a question. To simplify and to prove, it's simply one and the same thing. You are simply applying the basic technique or the basic approach. All right, so in this case, you choose which side to work with, and it is best always to try by all means to work with the complicated, the most complicated the part that has got a lot of things. And here this is on the right hand side. So we are going to take the right hand side, which is equivalent to 2 sine of x, sine squared of x, everything over. All right, so that is a sine squared of x over 2 tan x. So we have got 2 tan x, just write as it is, minus 2 sine of x cosine of x. All right, so let us see how this is going to be reduced from this part. Okay, simplifying, in this case, we do not have important things that we can reduce to say there's 180 plus this. We just need to know our basic trig. So it's best to remove things like tan, cot, and so on. And so we've got a tan there, where we know that the tan of x is equivalent to the sine of x over the cosine of x. We're also given. So this, we can just remove this and write it in terms of what? Sine and cos, or you can factor out 2, but let us start by removing this part. So meaning to say this here is going to give us the 2 sine squared of x, everything over. All right, so tan, like I said, it is going to give us 2 times sine x cos x. So meaning to say it is going to be 2 sine x over the cosine of x, like this, minus 2 sine x, the cosine of x from the other hand. But as we can check here on this part, we are having a fraction. So we can combine these two here. We can combine this to get a single term or a single fraction, meaning to say we are going to have 2 sine squared x over, we want the answer that we are going to obtain from these two. So let us try to simplify these two aside. So we have got 2 sine x over the cosine of x like this, minus 2 sine x cos of x. So this can be given as over 1. All right, so remember, on fractions, you simply have to find the LCM. So cos and 1 is going to be cosine of x. So we divide the LCM to the first denominator. So cos and cos will cancel, you remain with 1. So it's 1 times 2 sine of x, which is just going to give us 2 sine of what? 2 sine of x here. So we are simply going to obtain 2 sine of x minus cos x divided by 1. We are going to remain with cos x. We multiply to this part. So if we multiply by cos x, cos and cos here is going to give us a cos squared. So we are going to have cos squared x. All right, so this is the part that we are going to have from our simplification of the numerator, the denominator in this case. So let us just have this in bracket. So we obtained something like this, which is 2 sine x. So we are going to have 2 sine x minus 2 sine x cos squared x, everything over sine of x. So now you are dividing. Remember, on your division, if you are given two terms that are divided like 1 divided to a over b, it simply means 1 divided to a over b like this, which simply means 1 times b over a. You interchange this part once you introduce multiplication. So this is the same thing that we are simply having here. We are going to have 2 sine squared x like this being multiplied to, if we interchange this part here, because we are going to divide, then we interchange this part. So we are going to have the cosine of x on top over everything that we are going to have here. So this is the one that we are going to write in the denominator, meaning to say we are going to have the 2 sine of x minus 2 sine of x cos squared x in the denominator like this. All right. Now we are having a term that is under multiplication, and we know that under multiplication, we can simplify whatever way that we want as long we can be able to factorize. That means we can cancel our terms. So this part we can rewrite as it is times the cosine of x as it is. Then here we can factor out 2 sine x, which is common. So if we factor out 2 sine of x, meaning to say we are going to divide whatever that you factor out, you must divide here. So it's 2 sine x divided to 2 sine x, which is 1, minus this 2 sine x and 2 sine x give us a 1. So meaning to say we remain with the cos squared x like this. All right. So here there are 2 of them. So it's sine squared is same as 2 sine x times sine x. That is what squared means. There are 2 of them. So meaning to say this 2 sine x is going to cancel with 2 sine x. You remain with the 1 of the sine x that we are given. All right, so this is what we are going to have at the end. But now there's nothing to cancel. So what we are going to do, we are just going to combine. We are left with sine x. Here we are left with cos x. We are going to multiply these two. So it's sine x cosine of x, everything over 1 minus cos squared 1 times this part. We are going to remain with 1 minus cos squared x. So, but we are not yet there, because our answer here is supposed to be cot x. So you ask yourself now, what is it that I can do at this stage? You see that, all right, so let us see, there's 1 minus cos squared. So you can go back to our identities. Remember, the cos squared of x plus the sine squared of x is equal to 1. So what made us to obtain 1 minus cos squared? We simply transferred cos squared to the other side, so we remain with sine x. So the sine squared of x is equal to 1 minus cos squared x. So where there is 1 minus cos squared x, we can write sine squared x. So meaning to say this whole part was going to be written as the sine of x times the cosine of x over sine squared x. But remember what I said on sine squared x, it means there are 2 of them. It simply means sine x times sine x. We are going to see that we are going to cancel sine x and sine x. We remain with the cos over sine x. And what do we obtain from cos over sine? Cos over sine simply gives us cot x. And this is exactly what we had on the left hand side in this case. All right, so that is the simplification. The proving part, it's one and the same thing. Where there's a proof, you are using the same technique that you were working with whilst you were simplifying. So there's nothing so special about the word prove. It's only that you must obtain the exact answer as this one. Whilst on the proof answer, we can have two different answers, but meaning the same thing. But here you are supposed to have exactly. So you just have to revise your trig identities, your ratios, and so on. Let them be known as much as you can. And here we've got another part again to prove this identity. So like I said, proving and simplifying, it's one and the same thing. So here we are asked to prove that the sine of 180 degrees plus x. So this is sine 180 plus x is equivalent to all this part. All right, so we are going to take the left-hand side in this case. Let us work with the left-hand side, the most complicated side. All right, so let us check, guys. This one we talked about it. We are going to rush here. 180 plus x. Remember, 180 plus x is in the third quadrant. In the third quadrant, that's where we have got 180 plus x. And from our all students take calculus or the cast concept, this one is for tan, meaning sign there is a negative. All right, so sign is going to be taken as a negative. So you're going to have negative sine x multiplied to the square root of cos x squared minus 1. All right, we talked about cos x squared minus 1 previously. I'm not going to repeat this one. We talked about it here. If you still remember, we had cos x squared minus 1, isn't it? We did not. We have cos x squared minus 1. I think it was from the first one. All right, no problem. If it's like that, we're going to work with it. But here, cos x squared, oh no, this one was cos x squared 369. I thought like we had that one. All right, no problem. Let us have it. If it's like that, I can't see where I wrote it, but I just like feel like I wrote it somewhere. All right, no problem. So we're going to have this from the identity of where there's cosec, we've got 1 plus cot squared, 1 plus cot squared of x, which is equal to cos x squared. We are also given this in a formula sheet. So transpose what made us to have cos x squared minus 1. We transferred 1 to this side. So meaning to say we are going to remain with the cot squared x. So cot squared x is equal to cos x squared x minus 1. So that means where there is this part, we are going to write it as cot squared. So this one is going to give us the square root of cot squared x. All right, multiplied to sec 360 minus x. The first thing that we are focusing is sec, and sec it's from cos. So sec x is given from 1 over the cosine of x. So if cos is positive, sec is positive. If cos is negative, sec is negative also. So in the 360 minus x, remember, this is the last quadrant, the fourth quadrant, where cos is a positive. So it means also sec is going to be a positive. So we are going to obtain sec x being positive, all right? That's everything over 1 plus tan squared. We know that 1 plus tan squared is sec squared, all right? This one is the basic identity that you are also given. 1 plus tan squared of x gives us sec squared x also we are given. So where there is this, we are going to replace with sec squared x in this case. All right, so this is going to be sec squared x multiplied to cos 360 minus x. 360 minus x is the last quadrant, and cos there, it's a positive, so that will be cos x multiplied to cot 180 degrees minus x. Remember, 180 degrees is in the second quadrant, and this quadrant is for sine, meaning to say tan is going to be a negative. So also cot is a negative because cot is taken from tan. Cot x, it's 1 over tan x. So if tan is negative, cot is negative. If tan is positive, cot is positive. So since tan in the 180 minus x quadrant in the second quadrant, if tan is negative, it means cot also is going to be a negative. So we have got minus cot x there. All right, so that was the first part. Now we can simplify again, minus the sine of x, or we can even cancel some of these things here, or let us just simplify. Minus sine of x multiplied to the square root of cot. Simply square root and square cancel. We remain with the cot of x multiplied to the sec of x. All right, the sec of x, I can even cancel this one, guys, because we are simply having a repetition here. The sec of x here and the sec squared x can cancel. We remain with the sec x. All right, so here we're just going to have a 1. We can simply have a repetition here. All right, over sec x. Remember that sec is 1 over cos. So this is going to be 1 over cos x times the cosine of x times minus cot x. So this is what we are going to have. All right, now we can cancel and see what's going to happen on this part. All right, so let's try to cancel using our techniques here, that the denominator, the numerator to the denominator can cancel. Cot and cot can cancel. That's cot x and cot x. Also here, this part here in this denominator alone can cancel each other. So cos x and cos x can cancel. All right, so here we are just remaining with the positive sine x and 1. So we are going to multiply these two. That's sine x times 1. It is going to give us the sine x over 1. In this case, we are just left with the 1. So sine x over 1 is simply the sine of x. And this is exactly what we were given on the right-hand side. So as you can see, this is equal to the right-hand side. So this is how you prove a certain part of your identities or your ratios or whatever part of your trig. You need to work with the application of the identities and knowing your quadrants, especially the quadrants. You need to know them much. So because you are not given the quadrants in your formula sheet, you need to know them by heart, each and every quadrant, like I explained in our previous class, that it becomes x. In the first quadrant, it's just x. In the second quadrant, it's 180 degrees minus x. In the second quadrant, the third quadrant, it's 180 degrees plus x. The fourth quadrant, it is going to be 360 degrees minus x. So these are the ones that you need to understand or to know. All right, guys, that's it from Maison African Motives, working on mathematics N3. Till we meet again.